Hello students. Today we will be discussing about the last topic of this chapter, abnormal colligative property. Okay. So colligative properties, we know that experimental value of colligative properties of many solutes are equal to the observed value of the colligative properties. But in some cases, it has been seen that the observed value is not equal to the experimental value. For those solute particles, we think that is there are some abnormalities present. These abnormalities are being they considered by Van 't Hoff, and he has introduced a factor, Van 't Hoff factor, in order to mitigate this problem. Okay, so what is actually this abnormal colligative property? It is the difference, or it is the value which does not shows equivalence to the experimental values. Okay. Now, a factor which is known as Van 't Hoff factor which is represented by I, small I. Okay. So what is this Van 't Hoff factor? It is the ratio of the experimental value. I is the ratio of the experimental value of colligative properties to the calculated value of the colligative properties. Okay. So it is the ratio of the experimental value of colligative properties to the calculated value of the colligative properties. Now, what does it mean? It means I is equals to, if I am considering molecular mass, it will be normal molecular mass or molecular weight divided by experimental or observed molecular weight. Okay, like that. Now, how does this occur? Means, what is the basis of occurrence of this Van 't Hoff factor? From where does this Van 't Hoff factor actually comes? We have to understand that this Van 't Hoff factor is actually an equilibrium factor. Suppose I have we have some solutes which dissociates in aqueous solution. We have some solutes which associates in aqueous solution. So for those solutes which dissociates in aqueous solution or in any solution okay, it can dissociate anywhere. Not only it should be an aqueous solution, in non-aqueous solution also it may dissociate. Okay, like we have read in Finkelstein reaction, or we have read in reactions where we have seen that NaI is used to, I minus is replacing the Cl minus. Okay, NaI in acetone, it has been used to replace, to make Ri from RCl. Okay, so what happens here in acetone? NaI does not break like that. Okay, who breaks? RCl breaks, and that is why this type of aqueous, if I am talking about only aqueous solution, then other solutions will not be taken into consideration. So in any solution, if there is dissociation occurring, so those solutions can also be taken into consideration for understanding this type of problems. Now, suppose I have anything like I have A, which is going to get dissociated. Like if I'm giving AN, it will be forming Na like this. So initially, if AN is 1, okay, initially means at time 0. So Na will be 0. After time T and degree of dissociation alpha D, we will have 1 minus alpha D and N alpha D. Okay, we will have 1 minus alpha D and N alpha D. So here, if you remember in class 11, in equilibrium chapter, chemical equilibrium chapter, we have studied that these are 1 mole. First, initially it is 1 mole, then it is 0. We are calculating, when we used to calculate the value of Kp, we used to figure out the total number of moles from there. Here I is being used for that. I means the equilibrium concentration or number of moles, I minus alpha D plus N alpha D. I equals to 1 minus alpha D plus N alpha D. This is at equilibrium. Okay, so I is the equilibrium, whole number of moles, total number of moles present in equilibrium. So what is I? I is the total number of moles present at equilibrium. So from here you will say that you can take this alpha D common and you will get 1 minus N. Okay, you will get, N minus 1. You will get N minus 1 alpha D. So from here you will get I minus 1. This is N minus 1 alpha D. Okay, I minus 1 equals to N minus 1 alpha D. Understood? Plus alpha D into N minus 1. So alpha D will be I minus 1 by N minus 1. This is for the dissociation. This is for dissociation. My alpha D, degree of dissociation, is I minus 1 by N minus 1. Okay, this is for dissociation. Now, for association, what happens? For association, when solute molecules undergoes association, okay, like if you have Na, or you can say if you have Nb, from there you will get Bn. Okay, Nb to Bn. So initially this is 1 and this is 0. Same. After degree of association, after time T and degree of dissociation, not dissociation, it will be association. Degree of association alpha A, we have 1 minus alpha A, but in this case it will be alpha A by N. Okay, it will be alpha A by N. Understood? Because number of moles, N moles or N entities are being converted to 1. Okay, so it will be alpha by N. So 1 minus alpha plus alpha by N. Next, the same thing, I is equals to 1 minus alpha A plus alpha A over N. From here you will take 1 I minus 1. From here you can take alpha A common and you will get 1 by N minus 1. So alpha A, or degree of association, is I minus 1 over 1 by N minus 1. Understood? So this is how we will be getting the value of alpha A, or degree of association, for any solutes which are undergoing connection. Like if you have acetic acid forms a dimer in aqueous solution. So because of strong intermolecular hydrogen bonding. So like this, if there are association because of some physical forces or some chemical forces, they will actually undergo this type of you have to find their colligative properties using this type of formulas. Understood? Now, if I say for complete dissociation, if I take an example for complete dissociation, we can say that it is of NaCl. For complete dissociation of NaCl, we will say I is equals to 2. Any ionic compound, for any ionic compound, NaCl, K2SO4, okay, all compounds which undergoes complete dissociation in aqueous medium. Okay, if I am taking the aqueous solution, so there they will completely dissociate and I will be the number of ions formed. I will be equal to the number of ions formed from that dissociation. Okay, I think it is clear. Now, this I will be actually added to all the colligative properties. Like we have read pi equals to CRT. So it will be modified to, okay, pi equals CIT modified to for ionic, for solutes where they undergo dissociation, for solutes which are capable of getting dissociation. If you have glucose molecule, okay, C6H12O6, then I will be nothing but 1 because there is no dissociation occurring there. Okay, so glucose molecules, urea molecules, they do not undergo any dissociation. Ionic molecules like NaCl, K2SO4, aluminium sulfate, they undergo dissociation. Okay, Al2SO4 whole thrice, 2Al and 3SO4s, Al2SO4 whole thrice. So you do not have to actually see the charge, you have to see the number of ions they are forming. 2 aluminium, 3 plus ions will be forming and 3 sulfate ions will be forming. So I value will be 5. Okay, like that. So the modified version here is pi equals to ICRT. Okay, same goes for del TB equals to I into KB times M del TF I into KF, sorry, times N. Okay, even P0 minus P by PO means this is the relative lowering of vapor pressure will be I into mole fraction of the solid. Okay. So this is the effect of Van 't Hoff of the solutes which undergoes dissociation or association. And we have discussed that how we have to find out. So for the exam questions, the questions that will be coming in your exams for your boards or for your JEE, NEET or any other thing, there they will mention you how much the degree of dissociation is. Okay, they will give you the value of degree of dissociation, or they might not give you the degree of dissociation. They will tell you the name of the salt that will undergo dissociation, and from there you have to find it out by yourself, the value of I, and then you have to calculate the whole thing. Okay, so these are the few things that may come in the exam. Okay, let us try and solve one question. Okay, let us solve one question from here. One of my very favorite questions. Actually, it is a combination question from PYQ. Okay, previous year questions. Yeah, yeah. Question number 39. The elevation of boiling point of 0.1 molar aqueous CrCl3 X NH3 solution is 2 times of that of 0.5 molar aqueous CaCl2 solution. The value of X, you have to just find the value of X. Okay, assume 100% ionization for the complex and CaCl2. So for both the cases, they have told you to assume 100% ionization, means they are completely getting dissociated. Okay, here I think you can see the question. Okay, so this is the main thing, the elevation of boiling point of 0.1 mole aqueous solution, aqueous CrCl3 dot XNH3 solution is 2 times of that of 0.5 molar aqueous CaCl2. The value of X is, so here according to this question, you can simply say that you have to find out the value. Okay, CaCl2 will undergo complete dissociation. CaCl2 will undergo complete dissociation, Cl2 plus 2Cl minus. So I is equals to 3 for this case. I is equals to 3 for this case. So from here, what you have to do, you have to find some values. What values you have to find? You have to find this value. Elevation of boiling point, they have given you the molality, 0.1 molar. Okay. And CaCl2, they have given you 0.05 molar. So molality is 0.05 and I value. Okay. I value you have to find out from here. It's 2 times the value of this CaCl2 solution. Okay. 2 times of this CaCl2 solution. So elevation of boiling point is equals to I Kb into M. Okay. I Kb into M. So what will be the value of this TB del TB? They have in this questions they have asked you that 2 times the elevation of boiling point of this is twice of that of this one. Okay. So here del TB is I Kb times M. Okay. I Kb times M. So I is 3, Kb has not been given here, times M. What is the value of M here? 0.05. Okay. So this is the thing that they have given for CaCl2. Okay, for CaCl2. So what will be the value for del TB for the complex CrCl3 dot X NH3? It is twice of this. So 2 times K, sorry, 3 Kb times 0.05. So this is the elevation of boiling point for this TB. Okay. Understood? So now you have this value as 6 times 0.05. Okay. Now they have given you the concentration, the elevation of boiling point of 0.01 molar aqueous solution. So you have to just compare them. This is the value. Now for 0.01 molar CrCl3 dot X NH3 del TB, I'm just writing in bracket Cr, is I into Kb into M, 0.01. Okay. So you have to compare these two. You have to compare these two to find the value of I from this case. Understood? Hello?
Yes, sir.
Okay. Any doubt till here?
No, sir.
No doubt you have understood. Hello? Did you understand this part?
Yes, sir.
Okay. So you have 0.05. So this is 0.10. 0. Not 0.01. Is 0.10. Okay. Therefore, you have to compare these two. Okay. You have to compare this and this. Therefore, I Kb into 0.1 equals to 2 into 3 into Kb into 0.05. Okay. Understood? So 0.05 into 3. This is divided by 100. This is divided by 10. We will cancel them. Okay. 5, 2, and 2 will get cancelled. KB will get cancelled. So I will get 3 again. Okay. So we'll get I is equals to 3. So for this CrCl3 dot X NH3, I comes as 3. So what does this mean? I3, I equals to 3. What does this mean? This means that Cr, the complex Cr NH3 whole X will have one or two Cls in it. Okay, we do not know how many will be there out of 3, and there will be 2 others outside. So now as I is 3, previously we didn't know how many Cl will be inside. But now as you have these 3 means 3 entities. So for any coordination complex, the cation, irrespective of its charge, will be a single entity. Irrespective of its charge, will be a single entity. And in this case, it is more true. Why? Because here Cl is a univalent or has a oxidation state of -1. Valency 1 and oxidation state of -1. So only 2 Cls, Cl minus will be outside, whereas this 2 plus will be one entity. So from here you can say this is like this. Okay. So this is the 3 entities that will be formed due to the complete dissociation of this complex. What is this X thing? X is equals to, now, as it has been stated that coordination number is 6. It means chromium will be surrounded by 6 ligands. So chromium will be surrounded by 6 ligands. Therefore, X will be equals to 5. Okay? Clear? I think it is all clear, and you will be able to solve this type of questions. A value of X will be 5. Understood? So these are the few questions that are important, and like this you can solve all the questions in a very small amount of time. Okay? So bye bye. Good night. Okay.